Welcome to ECM University. I assume that you got here by way of thinksafety.coop by clicking on the test and videos link and then clicking on pulling and setting electric meters. This is a required course for ALTS 1, and once you have watched the video, you'll go back to thinksafety.coop, click on the same videos and test link. Under the video tab that says pulling and setting electric meters, or ALTS 1 pulling and setting electric meters, there is a tab that says test. You will click on that and go to the test site. Pulling and setting electric meters. This is a topic I think that sometimes we take for granted, and I think we also have a false sense of security while pulling and setting meters. One of the reasons for that is that typically what we're dealing with is household voltage, and sometimes we have a false sense of security and have a relaxed approach to safety on that, because basically that same voltage we allow our children to plug and unplug things into the wall. After this class, hopefully maybe you'll have a different approach or a different thought process or idea about that. There are some fairly significant hazards that we need to be aware of, and some methods that we need to explore as well. So, well, the objectives for this course are the things that we're going to look at is number one, qualifications of employees, proper terminology. Number three, inspection of meter base hazards involved. Number five, identify proper PPE. Number six, proper use of voltmeter, complete voltage checks. And number eight, procedures to set and pull meters. We will look at each one of those individually. Qualifications of employees. Number one, employees working on equipment over 50 volts must be qualified. Must be qualified employees. That comes from OSHA 1910-269-11. You can go there and look that up and read that for yourself. But basically, in order to be a qualified employee, you have to understand a few things. I'm not going to go through the entire list, but definitely the ones that are pertinent to us today. One is you have to be able to determine the voltage that you're working on, simply because there are different precautions, work procedures, PPE, and minimum approach. Another thing is you have to be able to understand the hazards and how to protect yourself from the hazards. And that's OSHA's main focus in regulations, is making sure that you are protected as an employee by your employer. And so another thing that makes you a qualified employee is understanding rescue procedures, what you would need to do in the event that someone was injured by the hazards that exist. So know the voltage, the PPE and protection for those voltage, what the hazards are, how we protect ourselves from the hazards, and then also if we were to be injured, how would we perform first aid or CPR rescue in those events. So we have other programs for those to make sure that you are a qualified employee. But just know that your first day on the job without any training, you would not be a qualified employee that would typically be able to set meters safely. Proper terminology. It's important that you know your cooperative's terminology for the items pertaining to a meter base. Meter socket, meter station. There are lots of different names for the apparatus itself. So being sure that when you're told to do something or discuss the hazards of a particular thing, exactly what they are. The terminology that we're going to use today is number one, meter base, which is the entire apparatus here. The lugs are going to be anything that where wire is connected or meters are plugged into. So we'll identify those as line and load side, also the neutral lug and grounding lug. So we'll talk about those as we go along. Insulated post. These are the things here. They're typically made out of plastic that keep the hots away from the knots. It's never a good thing when your hots come in contact with the knots, because they're not supposed to be hot. Okay, line side is always going to be the top side of the meter. The easiest way to keep up with that is knowing that that is the side of the meter base that we hook our line to. The line comes into there. And then number 5, load side, which will always be the bottom side, which the customer's load is connected to that. And then also the neutral lugs, which are typically here in the center, but not always. Sometimes they're to the side. There are a lot of different configurations of meter bases, but definitely they will have a neutral lug that our line side neutral will hook to the load side neutral. And then also the grounding lug. Typically, best place for it is here with the neutral, so that we're making sure that we're grounding that. And then also we'll have a piece of wire that goes from that and then goes down to our ground rod. Meter base inspection, check for socket damage. Now there are a lot of things that can happen to this meter socket. One of the things that can happen is in the way of damage is that these plastic insulators can become cracked or broken. Over a period of time they become deteriorated by the weather, the ozone, sunlight, if they remain vacant for quite a while. Another way that they can cause us problems is if they become broken. Now either you or the electrician, whoever hooks up the line side and the load side, if it's a brand new meter base, these are fairly strong, but definitely trying to get this tight enough, the line side and the load side wire tight enough in the lugs to prevent loose connections and excessive heat and premature burnout. Sometimes these become over tightened. If that happens, maybe these are brittle. The plastic insulators that separate the hots from the knots, they're very easy to break. So one of the things that we can do to ensure that they don't is one, we can support this with a pair of channel locks while we're tightening it. Also tighten it to the proper torque specifications for the meter base itself. Now typically we don't hook these up on an overhead meter base situation, the line or the load side. Now sometimes on an underground installation we do hook up the line side because we're running the wire to that. And then definitely there we want to make sure that we take proper precautions not to over tighten, under tighten, and also not to break the insulators, the plastic insulators. But also knowing that that is a possibility, we need to inspect that and be sure that they're not. Typically we will not be made aware of that when we're setting a meter because everything plugs in and the forces are against the back of the meter base. But definitely when we come back here sometime later to remove that meter, if these plastic insulators are broken, the guts and all that will come out with the meter base. The hots here on the top and the hots on the bottom, the line and the load side lugs, will come into contact with the grounded meter base, which will cause an arc flash situation, possible electrocution as well. Loose connections, there again, is something to be aware of. Typically on a overhead meter base, again, we don't make the line or the load side up, but something we can be aware of. Something you can maybe gently tighten that if it were a little loose, but definitely something we'd want to turn down and not be able to safely set the meter, and the homeowner or the property owner could get their electrician back out to tighten those. But just take a look at it: neutral lug, ground lug, line side lugs, and load side lugs. If they appear to be loose, they more than likely are. Foreign objects, all types of things can be left in here. We have some pictures later on in the program to show us some of those, but if a meter base has been left vacant without a meter on it for an extended period of time, lots of things can happen. Wasp nest, little green tree frogs, birds nest, they like to nest in there. So pay attention, be aware of that. Another thing with foreign objects, don't pull meters as much as we used to, collecting light bills and for disconnects and cutouts for non-payment and stuff. But a lot of times people, their meter seals and their tabs, if they use the tabs on the lugs, sometimes those get left there. They should not be. And then meter socket tension. This is where the meter actually plugs into, and it's not our meter base. And if it is a loose connection, it's definitely going to burn up the meter base and sometimes our meter as well, and it's also a trouble call. They make a neat little device called a meter socket lug tension tester, and you see that it has a flat tab here that is similar to what's on the back side of a meter. And what this device does is you actually take and push it into there where, just like the meter would, and then when you pull out on it, you see that it shows a red color here, or it would show a green color there. And when you pull out on it, what it does, if there's enough tension, it will pull a spring-loaded device in there out to the green part. If there's not enough tension, it will only pull it out to show the red part. So making sure that there's the proper tension before we set the meter is something that will help protect our equipment, such as the meter, and also maybe eliminate a trouble call somewhere down the road. This is not mandatory, but definitely a best practice. This is a different type. You see the green and the red here. So the same thing, you would connect this onto there, push it in, this flat part, into the meter socket itself, and then as you pull it back out, if we pull just a little bit to get it out, it's only going to activate, turn the dial to the red portion. Yellow's iffy, may need some attention, but if it gets to the green, we have to pull it hard enough to get to the green. Definitely that has the proper tension on it. Check for, still checking the meter base up. One of the things we need to pay attention to prior to setting a meter is the knockouts in the meter base, making sure that there are no holes in the meter base anywhere. That allows people to access there, kids stick things in there, potentially become electrocuted, and then also allows wasps and different insects and varmints to get in there as well. Make sure there aren't any holes and those knockouts have not been knocked out. Now occasionally we have to knock the knockouts out. If you're not familiar with what I'm talking about, these are these little tabs, and they're all different sizes and all different configurations in different places. For different size things, occasionally we have to knock these out ourselves. Say we were running an underground service and we had to access and get that into the meter can itself. So there's a proper way to do that, and I have a little video for us to watch to be sure that we're doing this properly.
In this video, we will be showing you how to remove the knockouts on a load center. As always, follow safety precautions and never work on utilized equipment. You'll notice that the knockouts have spot welds which connect them to the load center. This one has one, so you go to the opposite and that's where you'll knock it out. This one has two, so you'll go in the middle to knock it out. And if it has three, you just find your way in between them, and that's how you'll knock it out and remove it. With the knockouts, when you are removing them, you always start with the smallest knockout first and work your way outwards. Now we're going to show you how to remove the knockouts. For video purposes, I will be using a flathead, screwdriver, and a rubber mallet. So the first one, find the spot weld. I go the opposite, and I knock it out. Then you'll take your pliers on the underside and you'll twist it out. Now with the center knockout removed, I'll then work to the next ring. There are two spot welds on this, so I want to go in between, but this one I don't actually knock out. I want to pry this one up. Now you're going to pry up both sides of this knockout. Now you'll pull the two up together. Grab them both at the same time and twist out. So now with two of the knockouts removed, you've worked out to the next knockout. This one has two spot welds, so I'm going to go in between both of these to remove it. And this one is an actual knockout. And then you'll it'll twist it out. Now I've reached the size of knockout for my conduit that I was running, but if you did need a larger, you would still work your way out until you reach your adequate size for your conduit.
Okay, one at a time. I know sometimes we get in a little bit of a hurry. I have in the past, and tried to go to the correct size, the final size that I wanted, and sometimes end up knocking out more than I wanted to. So actually there's a fix for that. We'll cover that in just a minute. So once we've knocked our knockout, there are different kinds of things that we can use to fill that gap, and depending upon what we want to attach to it. Typically on an underground service, we're probably going to have a metal adapter that's going to glue onto our pipe, and then we're going to stick the threaded end into the hole that we've knocked out, and you either use a metal lock ring. If we're using metal pipe, we can use, they have some that has a nylon bushing on the inside of it to kind of help protect our wire if we're going to do some wire pulling or something like that, maybe pulling in an underground service or pushing or pulling long runs of wire or something like that. Just a little extra added protection. Never really seen an orange one before, but I thought that was neat. But that one comes with a plastic ring as well, a plastic lock nut. Probably not something that's going to be very sturdy, but definitely those are available and out there. Need to make sure that these are firmly seated all the way up, go all the way through, and then our lock ring is placed on the inside to keep it from coming back out. Here's an example here of a place that, something that we could run into. You see here your bottom pipe's probably an entrance cable coming from an underground service. It's going to run up through, there's going to be a channel here on the side that comes around and hooks into the top side. Off the bottom side of the meter comes over here to these breakers, and then you see a knockout there on the side, same metal adapter, lock ring on the inside. See, this one has the metal lock ring right there. Actually, we can expand that just a little bit and get that a little bigger. But see right there on the back side has the metal ring, and then also this plastic nylon bushing that goes on top there, kind of help protect the wire as we're pulling. But one of the things I want to point out about this picture as well is you'll notice that right here as well, it looks like they knocked the wrong knockout at first. So I know that tape probably accomplishes some of our concerns there, but definitely that's not a permanent fix. Not sure about the tape here and here, but that's not going to stay there. And if that were open, a kid could stick something that was metal, a coat hanger, a piece of wire in here and become electrocuted. Definitely if that comes off, wasp can build up in there, and that's something that we want to avoid. So actually there's a fix for that, and they're called knockout plugs. Is what I call them. They come in two different types. They come to different corresponding sizes as well, depending on what size hole you have. This is a plastic one, has a little metal keepers here, plastic keepers here. You just push it in, fill that hole. This is probably not something that we're going to do ourselves, but definitely something we're going to require our homeowner or our customer to do to make sure that meter base is sealed up and tight. And these are metal ones here. Probably a little more reusable. Metal tabs they push in, and sometimes we have to flare them out just a little bit to get a hold in there. But definitely want our meter base is sealed up. Don't want any holes in there with wasps and insects and stuff like that, and definitely don't want to have a kid that could access that and become injured. So here's a common problem here too with the meter base, is that it was probably originally done correctly, and this is probably the underground entrance cable, and it goes down and probably has a 90 on the bottom, and as the ground settles, that weight of that on that 90 pulls this out of there and pulls the next size knockout with it. And probably not something we're going to fix, but require one of our consumers. Actually, you see the lock ring right there that would come down and fit on top of this. So need to make sure that that's sealed up and in a good shape as well. They make a rigid conduit reducing washer. So if you inadvertently end up knocking out the wrong size that's too big for the metal adapter that you have, that fits on the size pipe that you have. You can get one of these things that will cover the gap, have the ring on the inside that your lock ring can hit on, and making sure that we're having that secured to the pipe. Okay. Another thing we're going to look at while we're inspecting this meter base and the breaker box that goes along with it, if it has that, is open spaces for breakers. That's something that needs to be fixed, needs to be covered up, and they make little blanks for those. It's just a little plastic tab. Never seen a metal one, but plastic tabs have the little keeper flanges here, and they just push into there, and making sure that that is closed up. There again, we don't want anybody to get injured in there, and also we don't want insects and stuff like that getting in there. Wasp nest. Wasps really like to nest inside of meter bases and breaker boxes. This was a fairly decent job here. This is an overhead meter base. You see that the line side comes in, has a little bit of a curve here. Don't need to make this too abruptly, and but it definitely curves in. Make sure that it lines up in here. You come in more of this angle right here and have to crook the wire right at the end. That's not good for the wire. It's going to make it more likely to break and cause problems down the road. And also you'll notice that the neutral is identified on the line and the load side. Talk about that more later on in the program. And then you'll see that their wire going to their grounding lug is a separate piece of wire. It's insulated as well. And actually they have it in conduit just to give it some extra protection. Now, if it does not have to be insulated or coated, but it definitely is beneficial to us if it is, and then it being in conduit, conduit definitely helps to protect it as well. Okay, here's one another decent meter base here. Things hooked up right. This is going to be some underground cable like we would run from our transformer out to our meter base. Has a orange stripe on a yellow stripe on it. Kind of help identify it from one end to the other. And then you also see the appliance ground here. If it is running in the same pipe, if it's running inside the same pipe, it does have to be insulated. Everything inside the pipe has to be insulated, kind of keep it from rubbing and chafing. Another thing I want to think about this meter base is somebody knocked out the wrong knockouts. Those would have to be plugged in order for us to safely set a meter here. We won't allow anybody access into here after we've sealed it up, and also the insects and the wasps and stuff like that. Okay, so definitely you'd want to get some knockout plugs and put in there, or get the customer to, and make sure that that's taken care of. Okay, now this one here's a mess. This one here is a mess. They've taken their wire and did a decent job of connecting here, keeping it from getting pulled out. But they've taken it and run it up to the top side, okay? And you're going to get your hots and your knots up here in the way of each other, okay? Then they've taken a bear and come off the bottom and gone to the inside. Okay? This is just a wrong way to do this. Your ground wire coming from your ground rod would need to come here. It can be bare. Make sure it's plenty of clearance between your load side that's going to be hot, and connect into there. Okay. If you're going to come over the top like this, it needs to be insulated. Really and truly, there's no need for this one going inside. If there is a need for an appliance ground to come from the meter base, this would need to be double lug, come off the bottom, needs to be insulated to run in this conduit with other insulated cables. Okay, here's another meter base, just showing some of the knots to do. Here again, you have uninsulated wire in with insulated wire. This is going to rub into that. Metal against rubber or plastic, there's a natural vibration there from the wind. Also, the electrons flowing up and down the wire, so that does not need to be bare. Okay, so that's a bare coming from the weatherhead, from up top's an overhead service. I also like this meter base here that it's double lugged here. If we did have to go two directions, here's one pipe going one place, another pipe going somewhere else, so it's double lugged here. Also double lugged on the neutral side here, so that would help solve some of the issues that we had with the previous meter base. But there again, if it's in the conduit, it needs to be insulated as with just like the others, the HOTS are. Okay. Here's one here. This is called tray cable. It's an old way of doing things. This is not sufficient protection. This would need to be in conduit. So that's not a good idea. Also, I like the color-coded cables. This is a good way for us to identify our neutral. On the weatherhead, it being yellow, it'd be a singular color all the way from one end to the other. Kind of helps with that. Okay. Here's a meter base that we definitely would turn down. There's lots of issues here with this meter base. One, they've taken their cover off, leaving all this exposed, and then you have this Romax that is not connected, or is it in conduit. Okay, it needs to be in conduit. If it's exposed, someone could be injured on that. And then also, this meter is turned upside down. It's an old analog meter. There's the wheel that turns, numbers of the dials, that should be on top, wheel on the bottom, so this meter's upside down. So probably think they're stealing electricity. Okay, so this is a neat job here. They have their ground wire that goes to their ground wire. They've put it in conduit, which is not a requirement, but definitely makes it look better and definitely protects it. So making sure, and then they've put the straps down here to connect it. You have probably your entrance cable here. You'll notice that it has some extra space here. This is an underground box. So what this is going to come here, probably turn and go through its own little channel that's protected, and then come over and hook into the top. Also, this is an expansion sleeve. The one that I showed you before, where the pipe had pulled through the knockout because of the settling of the ground, this is a sleeve right here that would help prevent that from happening. It's an expansion sleeve. It will slide a certain amount of distance to allow to compensate for that settling of the dirt. But also, that's one of the reasons that you want to loop your wire up high in the meter base and come over the top, so as this settles down, we have some slack here. Okay? All right. So let's look at some clearances on a meter base, some things that we need to look out for. One of the first things we'll look at is your drip loop above the roof. Has to be a minimum of 18 inches above the roof, inside of 6 feet. Okay, so 6 feet from this pipe. 6 feet from this pipe, say the service was entering from the side and ran along the roof for a certain distance before it got to the weatherhead. Inside of 6 feet from this pipe, the minimum distance your triplex can be is 18 inches. And even here in this situation where it comes in square, your drip loop cannot be any closer to the roof than 18 inches. Outside of a 6 foot radius from this pipe, radius would be half the distance of a circle, would need to be outside of 6 feet, would need to be 3 feet above the roof. Also here you'll notice that your service with residential pedestrian traffic only, no trucks, no horse riding, the lowest that we can be is 10 feet from the ground. That would include your drip loop as well. Okay. Another thing you need to look at is the distance of the last clamp where this pipe is secured. So you have your meter base screwed or bolted to the wall, however it is attached. The meter itself needs to be at 5 feet minimum and 6 feet maximum. So 5.5 feet would hit right in the middle of that. So 5 feet minimum, has to be at least 5 feet and can't be more than 6 feet above the ground. And then where this is attached and secured and strapped to the wall or wherever has a distance here of A. So we look over here at this chart to the right. For 2-inch pipe, 2.5 feet from where our service entrance is going to attach to the conduit. That attachment is 6 inches from the top of the pipe. Okay, so if we have 10 2-inch rigid conduit, not EMT or anything like that, but rigid conduit, it's 2-inch. This can't be any more than 2.5 feet from this point to where our service entrance is, and there again the service entrance attaches to the pipe at 6 inches below the top. Okay, 2.5 inch pipe can be 4.75 feet, 4.4 3/4 feet. 3 inch can be 7.66, would be 7 3/4 feet, and then 3.5 feet it can be 10 and 2/3 actually. That would be 7 2/3, 66 would be, and then this could be 10 2/3 feet or 10.66 feet. So where the last place this conduit is strapped to the wall. So it's connected to the meter base right here, and then would periodically need to be attached to the wall as well to support this weight and this pull of our service entrance, our service coming into and attaching to the pipe. So 2 inches is probably what we're going to see, so no more than 2.5 feet between these two. So it would need at least one strap, and it can't be any more than 2.5 feet. Now you can go inside here between the rafters and do some bracing there as well, depending on the angle of pull. That's another thing that has to be considered with this as well. So I drew this little diagram, and we'll assume that all this area is roof. Okay, the gray area on the outside, the brown area inside the circle is roof. Okay, and we have our pipe that comes through the roof right here. So 6 feet away, 6 feet away from this pipe, it has to be at least 18 inches. Can be as low as 18 inches below, between it and the roof. Okay, outside of the 6 inch diameter or radius, it has to be 3 feet, depending on the angle in which it runs in. So that's just something to be mindful of. That is a meter base that we could not set a meter on if it didn't meet that requirement. Okay, here's one we don't see as much because the height requirement has changed. But a meter base mounted in weatherhead under the eave of the house. I will remind you that the lowest our wire can be, our electricity in any wire can be 10 feet if it's pedestrian traffic only. If only people have access there. Now if you have trucks or people riding horses or stuff like that, it would need to be a 12-foot minimum, even to your drip loop. So if it was going to be less than 10 feet, your drip loop when it came down, and we need to make sure that we have a drip loop there because we don't want water running inside of our weatherhead. If it's going to be less than 10 feet, this pipe would need to extend through the roof. And then after it extends through the roof, it needs to be sealed. Okay, it needs to have a weatherhead on top. Be sure rains will not get in here, and also the roof needs to have a rain cap on it as well. That seals the roof. No one plywood getting rotten. Okay. All right. So here's another thing. So we've inspected our meter base. Everything's good with it, and we need to think about hooking it up and setting our meter. Okay. So when the wires, and this is real short, I know, but when our load side here is hooked and comes out the top of our weatherhead, a lot of times they'll put some white tape on one and the white tape down here, but we really don't need to trust that. We need to be able to identify our neutral so that we can be sure that we're setting or hooking up the right voltages in the right places. So make sure we have our hots and our nots separated. So we're going to need to identify our neutral. There are a couple of different ways to do that. I'll go over both of them with us. But one of the things that we're going to need is we're going to need a multimeter, and we're going to need to set that multimeter to ohms, okay? And then we'll notice when we do set that multimeter to ohms with our leads separated, it shows an infinity here. Infinity, an infinite amount of resistance. So there's no continuity here if the ends of these meter leads are not touching. So it's an infinite amount of resistance there. So the meter's maxed out. So we're measuring resistance. There's an infinite amount of resistance here, so that it would show an overload or 999, just a high number there. Okay, so we need to test our meter to make sure that it is working properly. So we want to take and touch our leads together here, and now we would have continuity, which would be 0 ohms of resistance, so that we know that our meter's working. If the meter leads are separated, we have an infinite amount of resistance there because there's no continuity between the leads. And then if we take and touch them together, it's going to be 0 ohms of resistance. A lot of meters will beep when there's continuity, okay, where there's no resistance. So we're going to be sure the meter's working. And then the next thing that we want to do is in identifying our neutral is that we want to take, it's a couple of different ways. One of the first way we're going to look at this is you're going to take a piece of wire and connect your 2 line sides together, okay? So there, once we take a piece of wire and we take and connect them together, there's continuity between those two. So then we're going to go up the ladder with our meter base, our multimeter, set it to ohms, and we're going to strip all 3 of them out, and we're going to touch it to 2 of them. Now, if we have our line sides connected together, which would have continuity between those two, and we touch 2 to 2 of our wires, and it shows an infinite amount of resistance, which one is our neutral? Well, actually, we don't know because we're looking for continuity between these 2 wires, right? So we want to identify our 2 hot legs, and then our odd one is going to be our neutral, okay? So if we take put our wire across these 2, and then we touch the 2 leads, and it shows 0 ohms of resistance, that means that these 2 are these 2. So then we would ask the question, which one is our neutral? Well, obviously, it would be the one not being tested if we touch 2 together and it shows 0 ohms of resistance. That's showing continuity, okay? Another way to do that is that you can go up the ladder and strip out all 3 and touch 2 of them together and use your voltmeter or your multimeter to ohm out down here at the bottom. But either way, we have to connect 2 of them and find the 2 that have 0 ohms of resistance between those 2. If it's the 2 outside ones here on the outside of the meter base, then the odd one, the one that left, would have to be our neutral, and then we would hook our bare wire from our triplex to that, our 2 insulated ones to the other 2 that ohm together, and then we would know that we got our line side voltages where they should be and our neutral connected where it should be as well, okay? So hazards, some of the things we need to think about once we have hooked up our meter base and we've made our service hot. We're getting ready to set the meter, so we need to be aware of some hazards that are involved here. One is electrical faults. Anything that's hot that touches something that's not, that's grounded, there could be an electrical arc, an electrical fault, okay? And we'll talk about fault current in just a minute and see how that could help hurt us. And also we need to be aware of our environment. One could be the environment inside the meter base. I'm talking about some things in there in just a second. But the environment where we are. Is there a dog there that could bite us? Is there a customer there that's distracting us? Is there a customer that could reach in here and touch something that they shouldn't? So we need to make sure that they're standing back out of the way. And then also making sure that we have firm footing where we're standing. A lot of people like to pile up stuff around their meter base and different things, so bushes, vines, stuff like that. Make sure that we're taking care of those, and taking care of those, we're taking care of ourselves, okay? So the customer, I already talked about them being exposed to a hazard, but could they be a hazard to us as well? Yes, if we're there setting a meter for an irate customer, our attention needs to be on them until they're situated. Also, they become a distraction to us as well, and we may miss one of our steps. Breaking glass. Most of our meters are plastic now, but definitely some of the ones that used to be old meters that are glass. That glass breaking. It's very thick glass. When it cuts very deep. Any type of gloves in de-energized condition, our leather gloves, energized condition, our rubber gloves, would offer, with the protectors on them, would offer us some protection. Also, we protect ourselves through proper work procedure. One of the things that happens when this takes place is that people want to hit the meter. They line up and set the meter. You always want to put the load side in first, line up the line side, make contact, and then firmly press the meter in there. If there is good tension, meter socket tension on these lugs, it's going to be difficult for it to get in there, for us to push it all the way in. Where people make the mistake is taking their hand and hitting the meter to drive it in there. and that's typically where things go wrong. What needs to happen is some type of lubricant. We used to keep stuff on our trucks called 226. It was an oily chemical, and that also improved electrical connections. So you'd squirt just a little bit here, either on the lugs, the tabs on the meter, or put some here on the meter socket. Definitely would help us be able to ease that in there without having to hit it and injuring our hands. Insects and varmints. Like I said, a lot of wasp nests, stuff like that, making sure the meter base is sealed up keeps that from happening. If they're in there, we may need to spray them, clean them out, but definitely clean them out of there and make sure that they're not causing us any problems. Fault current. Fault current, there again, I think we have a false sense of security in meter bases simply because it's household voltage. Sometimes we take it for granted and think that it's safe. But fault current in a meter base can be extremely high. And fault current and arc flash go hand in hand. And I've got some videos in just a second that show that to us, what actually could happen. But we can figure the fault current in a meter base. So what you would do is take the kVA, multiply it times 1,000, which would give us the total VA, the volt amps, and then take the total volt amps and divide it by the secondary phase-to-phase voltage. So if it was a 120-240 transformer, you would want to use the 240 voltage, and that would give us the full load secondary amps that transformer can deliver at 100% load capacity. And then we want to take and divide it by the impedance of the transformer. And I have some math here for us. Some ideal situations that we typically would run up on would be a 25 kVA transformer, secondary voltage of 120-240, and an impedance of 1.7%. So notice that that is a percentage. So in multiplication, we will want to move the decimal 2 points. So 2 places, so we're going to use 0.017 in our calculation. And this is what that looks like. So you take the 25 kVA, multiply it times 1,000, gives us 25,000. Excuse me. And then you're going to take the 25,000 and do the full the phase-to-phase voltage, divide it by 240, and that transformer, that 25 kVA transformer, can deliver 104 amps. To get the fault current, then we divide the percentage of our impedance, would be 0.017. And if you do that math, it comes out to be 6,117 amps of fault current. Now, a lot of our primary lines don't have that much. Some co-ops, they're higher than that, but on average, we run around 4,000 to 5,000 fault amps of fault current on our system. So in a household, on a residential meter base, you could have up to 6,117 amps of fault current with a 25 kVA and a 1.7% of impedance. So have a video here that we're going to watch, and just kind of shows us what could happen if we're exposed to that type of fault current.
In real time. Now the same from different angles. And now in slow motion, we can clearly see the enormous impact of the arc.
Okay, through this video you can see the need for proper PPE and also proper work procedure, where you stand and how you position your body. One of the more common places when you plug in the meters, everybody wants to look in there and make sure that the lugs are lined up. The meter lugs are lined up on the socket. So standing to the side, keeping your head turned, hard hat, face shield, safety glasses, arc rated clothes, and energized condition, definitely rubber gloves. So the minimum approach distance for the smallest voltage that we're exposed to is 122.40 is avoid touch. Well, to avoid touch and something that you could touch, what you would need to have some type of rubber protection to make sure that we avoid that. So here's another video that shows an arc flash situation in a box in 480. And one of the things you have to think about and consider that in a meter base, all of this arc flash and arc fault current is going to be in one direction and into the direction that you are. So take a look at this 480 and you'll see how violent it is. 480 is a voltage that we should not work energized. We should not work it energized. 480 is a voltage that will self-sustain until it actually burns itself in the clear. We should not. See how violent it is, how hot, how far it comes out. So if you have 480 in a self-contained meter base with very large wire, that's going to be very devastating to you. Okay. So the next video that we're going to look at, it's relatively short, 29 seconds, I think, maybe just a little longer. One thing I want to make evidently clear is that meters are not switches. There's actually an OSHA standard that says we should not make or break connections unless we do so with a load break or load make device. And meters are not one of those. And now this is contrary to the way that I was trained. I was trained that if it's you think there's a lot of load on it when you're pulling it, pull it fast. And if you think there's going to be load that you're going to pick up, set it fast. And that's not correct. That is improper training. Meters are not load break or load make devices. So if there's any load that could be picked up or broken there, either that load needs to be removed or the entire thing needs to be de-energized. And here's an example of that.
And measuring devices, and trying to pull a meter could be the last thing you ever do. Watch this experiment. This is what can happen. Measuring devices, and trying to pull a meter could be the last thing you ever do. Watch this experiment. This is what can happen when you pull a meter and it shorts out at the base. Pretty, huh? The possible burns, eye damage, or even loss of life just aren't worth it.
So, inside of that meter base, we have no way of knowing exactly what's going on. So really and truly removing a meter and installing a meter, once we've done all of our checks, installing should be done in de-energized condition. It's just safer to do that. It's one of the ways that we can ensure our safety. And then anytime that we're pulling the meter, we should de-energize that as well, because there's no way to be able to determine the condition inside of there. If you have the plastic insulators that are broken or something in there that we can't see, you see how violent the arc flash is and how dangerous it could be for you. Okay? So OSHA, the APPA safety manual, and the National Electric Safety Code identifies some safety equipment, personal protective equipment that we should have on while setting and removing meters. First thing is a hard hat. We know that pretty much anytime we get out of the truck we should have that on. Safety glasses and face shield, use those in combination with each other unless the safety glasses are protecting you from UV rays as well, the bright light of the arc flash. And then rubber gloves. There again, I've already said it once, rubber gloves should be worn while setting and removing meters in energized condition if you choose to do that. And then FR arc rated clothes, you probably already have those on. Shirt sleeves rolled down and buttoned, your shirt's buttoned up, not all the way to the collar, but buttoned up all the way to the, I guess, one hole down from the top. And then if you're working in de-energized condition, leather gloves. Pretty much everything that we do, we should have some type of hand protection regardless of what we're doing. Use of voltmeter. you should be familiar with the device that you're operating. If you're not, you should read the operator's manual to learn how that piece of equipment or device should be used properly, and making sure that you are set to the proper setting on your multimeter, and then also make sure that the leads are plugged into the right place depending upon what you are measuring. Now, not all voltmeters require this. Some are multimeters, they digitally range and swap to the different things, but this one has, depending on what you're hooking, what you're testing. Here you would test for volts and resistance on the same lead, but over here would probably be for current or something like that. It would need to be plugged in somewhere differently. Okay. The settings, direct current, which we very rarely use, will be depicted either by a DC or a solid line, or a solid straight line, or a broken straight line. Alternating current will be designated by an AC or a sine wave, and then ohms will either say ohms or have an omega symbol, making sure that whatever you are testing or measuring, that your voltmeter is set to the proper setting. Now, if something is energized, you should never check for resistance. This will cause catastrophic malfunction and failure of your multimeter. Okay? Some meters have protection for it, but most do not. Okay? So there again, always read the manufacturer's instructions of the voltmeter to ensure that you're using it in the proper way. Okay? So proper procedures for voltage checks, which is what we have now made our way to. I do want to talk to you about two accidents that occurred. I have some pictures of one of those as we go along. But there are three things primarily that we're looking for when we do the voltage checks inside of a meter base prior to setting a meter. One is that the line side voltage is right and in the correct place. Okay. The second thing is that the load side is not grounded, and then also that the load side is not tied together. Now, the first incident where this did not take place and someone was injured was actually on a place where it was a piece of commercial rental property, and the person that was no longer renting the property had called the electric cooperative and asked them to remove the meter. Back then they had to remove the meters in order to disconnect or discontinue service. So the serviceman goes out there, he pulls the meter, puts a cover on it, seals it up, puts the meter in his truck, and he leaves. Most always when that happens, the new tenant that is renting something, or the owner, wants to do some work in there, so they call and have the meter turned back on. And so actually this happened. Serviceman been gone 10, 15, 20 minutes, maybe an hour. Dispatcher called and said, hey, I need you to go back by there and set that meter. And so he does. He goes back by there a couple hours later, takes the cover off, takes the glass cover off, plugs the meter in, and the meter exploded. What actually had happened was the tenant that was moving out had done some electrical work inside the building. When he was leaving, he was going to leave, was not going to leave his work and his electrical panel in there. So he went in and took the inside breaker box out, and to get it to go back through that knockout, that hole that they're fed through coming from the meter base, he had to take all the hots and the knots and twist them together. So had he tested for that, even though the meter had been taken off and he was putting it back on in a short amount of time, had he done his proper checks each and every time before he set a meter, this would not have happened. Okay. There was also another incident where the proper checks were done. The voltmeter, inside the meter base was the proper voltage, but the meter did not match the voltage that was inside the meter base. It was 480, the meter was a 12240, and it exploded. I actually have some pictures that will show. So making sure that the line voltage is what it is, and what it's supposed to be, where it's supposed to be, and also make sure that it matches the meter that we're fixing to set. If you're setting a 12240 meter on a 240 480 or 277 480 meter base, that's not going to work. Meter's going to blow up. So you want to make sure that that's not happening. So So one of the first checks that we want to make is that we want to take and put our voltmeter, our red hot lead on the line side lug and the what we assume to be the neutral, and we should get 120 volts. But right then we don't know if which one of these is hot. Okay, so we want to check the other side and make sure that we get 120 volts there as well. So we know that now this is our left side line side from there to ground is 120, and our right side from the line side to the ground is 120. So we know that our two hots are at the top and our knots is in the middle where it's supposed to be. And we can double check that and verify that by testing across the top and getting a potential difference between the two line side lugs of 120 volts. Okay, this would be the hots where they're supposed to be, the knots where they're supposed to be, and then also making sure that we have the proper voltage. Okay, so the bottom side of the meter base is equally as important to test as the top, but however is one that is often skipped over, and it should not be. We should make sure that we're testing the bottom as well. There's two things here. One, we want to make sure that it's not hot. Three things. One thing is that it's not hot, it's not grounded, and the load is not tied together. Now, the load not being tied together is very difficult to do unless we can get the load side breakers turned off or disconnected. If not, this is going to be almost impossible. I still say that we should not set the meter, but definitely should not set it energized if we cannot complete our checks. Okay, so the first thing that we want to do is we want to check from, we've already established that this is the neutral, to the bottom side and make sure that it is not hot. Okay, it should read 0 volts. We have it set on volts. We're checking for voltage. There should not be any voltage on the bottom side of the meter base, and then we should check that on the other side as well, and making sure that there are 0 volts here, and making sure that the load side, left side is not energized. Okay, the next thing we want to do is check the right side source to the load. And what we're making sure here is we've already established that from here to here is a potential difference between ground and here is 120 volts. So we want to check from line to load side to ensure that the load side is not grounded. Okay, if the load side was grounded here, we would have got 120 volts here. So making sure that the load side is not grounded, and we want to do that on the other side as well. Now there's an alternate way to check this as well. Okay, so making sure that this is not grounded. Okay, the next thing we want to check for is making sure that our load side is not shorted together or tied together. And one of the ways, there's two ways that we can do this, is we can take a short piece of wire and ground one side. So if the two load side lugs are tied together inside by a device, or the wires twisted together, or a nail nailed through a piece of conduit or a piece of Romex, if we ground one of them, we would essentially be grounding both of them. So by grounding one of them, we've already established that they're not hot. So then we can make sure that they're not hot. Then we could ground one of them. If we grounded this one also would be grounded. And if we check here with the voltmeter on voltage, it would read 120 volts if they're tied together. Okay. If they're not tied together, it will read 0 volts, and that's what we're looking for. Okay. Another way to do that is take the voltmeter, the multimeter, and put it on ohms. Okay. And we want to make sure that when we check across here, that the meter actually reads 99999, what it says here, and make sure that it is there's an infinite amount of resistance between these two. Okay, if it were to read 0 like this, 0 resistance, that means that the load side is tied together either by a device, or that the wires are twisted together, or there's a nail or something that is connecting the two together. Okay. So those are the 8 simple steps to live by. I actually have some handouts that we're going to hand out to you in class to be sure that you have those, and you can refer back to that on the job site as well. Okay? Okay, we're going to go through a couple of checks here and some scenarios and find out what's wrong here. So group activity, we'll go over this in the classroom as well and have a little participation. Hopefully you'll be familiar enough with it to be able to answer the questions correctly. So if we check from our line side to our load side like this on volts and alternating current, and we got 240 volts, what would be the problem? Well, the problem here would be that both the line and the load side both are energized and they're opposite legs. Okay, so there'd be a potential difference of 240 volts between these two on the line and the load side. We know that there should be zero voltage on the bottom. There's probably still in some power or there's some backfeed from somewhere, but definitely that'd be a meter that we could not set safely. Okay. Next scenario, scenario 2. We've checked from what we assume to be our neutral lug or our ground lug to our line side lug on the right side, and we get 240 volts. What would be the problem here? The problem would be that we actually have hooked our weather head up wrong, probably more than likely, and our neutral is hot. If we check from over here, we're probably going to get between these two 120 volts, but we're only going to get 120 between these two as well. So we've probably made our neutral hot on this one if we get 240 volts from our neutral to our line side lug. Next one, scenario 3, what is wrong? So we have our grounding strap here. Essentially we've grounded this one. And then we check with our own voltage from our line side to our load side. If we get 120 volts, as the voltmeter shows here, it means that our secondary load is going to be tied together in some way or another. Okay, so what would be wrong here? We check from our neutral to our load side. They're going to have some backfeed here. Okay, so the bottom is going to be hot. That is a meter that we could not set safely. Okay, so we're on resistance here, and we're testing across, and it shows zero resistance. That means that our load side is going to be tied together either through a device, nail or a screw, or the wires are just twisted together. So we would not want to set that there. Okay, so inspections of a meter base. We're going to run through these fairly quickly, show you a couple things that typically could be found while we're inspecting a meter base. Okay, this one right here there's a band inside there. Okay, the band is what connects the meter to the meter base lid. Okay, so and it's on the inside. If you were to make this hot, it probably would touch these or had the potential to fall down across these two and short them out. So I want to make sure that you get that out of there. Okay. Jumper cables right here, got this service jumped out. Got the jumper cables there run down probably to the bottom side, the load side of the meter socket. Okay. This is something to pay attention and be aware of. Got your entrance cable coming here and going to the weather head, but they've taken and run some wire inside the building, inside the house, that comes off above the meter. Okay, so just borrowing a little bit. Okay, so make sure that that's not like that. Here's a meter that's strapped out by some little tabs. You make that hot before you go and check it, and something's wrong here on the bottom side. We could have some problems out on the transformer. Okay. Just a little Romex across the top and the bottom. More jumper cables. I don't know if any of y'all, probably y'all don't, a little young, but for the game, play the game of Operation. We had to reach in there and get little pieces out without the buzzer going off. This dude's must have been pretty good at it. But if it not been for this rubber insulation right here on his jumper cables, probably would have been an issue. Okay, hooked on the weather head, running this LB right there. Took the cover off, running in the house. This one right here, you have to look. There's a lot going on here. So we have our line side comes in, but they also have some that comes off the line side and goes in that pipe. Okay, it's not going to another meter base. If it were, we would have another weather head. So they're stealing there. So pay attention to things like that. Should only be the wire going to the weather head hooked to the top side. This is where they set the 12240 meter on a 480 service. And you see how devastating it was, burnt the meter up, burnt the lugs slam off of it, completely off of it. They're not even there anymore. Okay? And just burned up everything. Guy was injured, recovered. But Definitely want to avoid that. Tapped on out here on the triplex. Just a little twisty action there. This dude, how many kinds of wrong here? This dude stole power so much they just put his meter base up where he couldn't get to it, and then he still got up there and jumped it out. So anyway, energy saver switch. There's little wires here to go to the grounding tab of the meter. Guy had him rigged up, had a switch inside the house where he turned the meter on and off, whether it would register or not. Electricity still flowed through the meter whether it registered or not. This is a bypass handle right here that they have bent down. There's another tapping on mid-span. Some more jumper cable action. And so, setting the meter, are you ready? The inspection's complete, PPE's on, voltage checks have been done correctly. You want to turn the customer's main off. Don't want to pick up any load with the meter. Stand to the side, set the load side first, push the meter in, don't hit, and install the cover and the seal. We've talked about that stuff extensively earlier in the program. So, pulling meters, wear your PPE, turn off the customer's main. This is not a load break or make device. Do an inspection. Do not pry the meter out while energized. You can try to pull a meter out with your rubber gloves, face shield, hard hat, arc-rated clothes on, but if it's taking an unusual amount of force to get it out, probably want to go de-energize it before you proceed. Also make this little device as a meter puller. If there was a problem or arc flash, it would be contained inside and directed away from you. But also it helps use some leverage there to help pull the meter out, some of those that are just a little sticky. Okay, so review: PPE, inspection, proper voltage test, proper procedures for pulling and setting meters. Okay, and if you have any questions, you can email me at crockett@ecm.coop. Crockett, CROCKETT, @ecm.coop.